The atmosphere is the region above the lithosphere and beneath outer space, which is about 700 kilometers thick, as generally described by scientists, and consists of five subcategories: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere, which is often considered outer space. As you climb higher and higher, the air pressure significantly reduces. It's 1,000 millibars approximately at sea level, which drops to 850 at 1,500-meter altitude. By the time you reach the stratosphere at 10 kilometers, it is down to 250 millibars, which is completely unbreathable, to just 1 millibar in the mesosphere, to zero point zero 0.01 millibars. Barely anything. Molecules don't collide in the exosphere. Despite the atmosphere being so far up, you might think there is no point in knowing this, but there are many uses of the pressure. Airlines, weather balloons, rockets, missile defense systems, and satellites all rely on the lower air pressure, the lower drag, the lower air resistance. Airliners cruise above 10,000 meters as the air resistance is so much lower than the surface, meaning it requires less fuel to propel the plane and keep it at the same speed, meaning flying high is more economical. However, flying too high, when there is even less air, whilst you might get even less air resistance, is more expensive due to having to climb higher and descend earlier, and it is hard to produce sufficient lift in the air if it's so light. So the middle ground of about 10,000 meters is reached. As you get higher in the troposphere, the temperature reduces due to the reduced density of the air and greater distance from the Earth's core. However, in the stratosphere, temperature increases due to the ozone layer and those chemical reactions, and convection as altitude increases. However, even at the stratopause, the temperature remains much colder than the surface, fundamentally differing from the troposphere in that regard.